Alright guys, this is the fifth time I've tried to record this lecture. I'm praying it works this time. Um, let's get started. This is not a video about how to make a graph. I fully understand that you guys know graphing. This is instead a video about how to get full credit on the AP Physics test on graphing questions, and also on my test because those are going to be AP questions as well. There's a lot of little nuanced and nitpicky things that the scorers are looking for, and I want to go over those here. When you get a graph, there's two things they could make you do with it. You could either be given a set of data and be asked to create the graph, or you could be given a graph and be asked what it means, to interpret that. So, for the first of those two, for the creation of graphs, I want to take you to the College Board website. Here he goes. Alright, I want you to read the top paragraph, pause now, and when you're done, resume. The most important thing to know about these verbs is that each of them, like it says, has a very precise meaning. And I want to talk about two of them right now, sketch and plot, the last two, because those are pertinent to this lecture about graphing. So I've highlighted the important information. I'd like you to pause now and read what's in blue. Here's all you really need to know. The AP Physics test is difficult for a number of reasons, but the biggest one for a lot of students is time. They run out of time. Sketching doesn't take as much time as plotting, so you need to know that difference in case you get a question that says sketch. You don't want to waste time scaling axes and all that stuff. So I want to show you an example question now. I'd like you to pause and read what's on the screen here so you understand the question. So my best guess is a lot of you guys read this and said, I don't know what a nonlinear spring is. How am I possibly going to solve this problem? The purpose of this video and this question in particular is you don't actually have to know what a nonlinear spring is. I will teach you that. That'll be second semester. But this is really not a spring question. This is a proportionality question, and that's something you do know how to do. Looking at part A, it asks us which quantities should be graphed in order to yield a straight line, etc. So we're basically just doing linearization. Well, there is no easier linearization question than the one you're looking at right now. The reason is that the only purpose of linearization in the first place is to eventually get an equation that relates to variables. In this problem, we are given the equation right here. F of x equals ax squared. That means we already know the proportionality. It turns out that once you know the formula, as we do here, the proportionality, which is again the same thing as what you need to do to linearize the graph, it's just the two variables, which are x and f, raised to the powers in the equation. So the correct answer to A, what should be graphed to yield the straight line, to linearize, is f, which is already to the first power, so no manipulation required for f, and x squared. That's it. If you can just do f and x squared, you get part A correct. Part B is asking us to calculate the values we have indicated. So, because we have specified that f is going to remain unchanged, but x is going to be squared, we're going to take these values of x right here below the header x, and we're going to put them squared over here in these blank data cells. Quick note about that. If you see blank data cells, it will always be worth 1 point minimum and sometimes 2 points out of a 45-point test just to fill in those cells. It is very, very easy to get these points as long as you understand proportionality and how to linearize. So now that we know we are squaring x, we're going to do two things. We're going to first put the header, and that means we're going to put not only x squared, but its units are going to be squared as well. So it'll be x squared, meter squared, and then all 5 of these values are going to be squared in these blank cells. I'm going to take you to the scoring rubric. Here it is. And you'll see this was a 2-point question. You get 1 for a correct column label, including units. So just putting x squared, meter squared, there's a point right there. 1 out of your 45 points on the test. Another point, just for taking all 5 values here and squaring them. And you get to use a calculator on the test. Couldn't be easier. Okay, we're going to now look at part C of that same, here we go, of that same question. Part C go ahead and pause and read, and also read part D. So what you see here is that we're asked to do something very particular. Plot. Plot is something we have to understand the meaning of. It means you must scale the axes, and although this question is a little unusual, it actually tells you label the axes with the variables and appropriate numbers, blah, blah, blah. Normally it doesn't say that. Like, this is about 10 years old, this question. Now, they don't give you this last sentence. They don't throw you a bone at all. They just expect that you know the word plot means to do all of those things that I've now highlighted. So, once you've plotted them, a few things that you have to be very careful about. You'll notice it doesn't say, draw a best fit line through the data. I don't know why, and I personally have a bit of a problem with the College Board for this, but it will almost always be a requirement that if the data you plot, and I'm using that word very deliberately now, if you plot data that turns out to be linear, and we know this data will be linear because we just linearized it, you must draw a best fit line that passes roughly through the center of data. Now here's where a lot of students lose the stupidest point on the AP Physics test. If you, I'm sorry, it's really that dumb. If you draw a best fit line that just looks pretty good, you'll lose points unless you meet these absurd requirements. I'm not kidding. Here's what they say on most rubrics. The best fit line must be drawn such that an approximately equal number of data points lie above and below the line. Now, if you have any experience with actual linear regressions, you know how absurd that is. But that's what they want, so do what they want. I'm going to show you now the scoring rubric with a sample graph. Here we go. And you'll see that this line does exactly that. So this first data point above, then below, below, above, above. Since there is an odd number of data points, you can't do a perfect 50% above, 50% below. But 2 and 3 is as good a split as you can hope for. Okay, so now that you know how to do that, the last thing to talk about is part D, which asked you to calculate A. This equation is in slope-intercept form. Because the graph passes through the origin, there is no B, or intercept, and therefore f equals ax squared is functionally y equals mx, where f is what's being graphed on the y-axis, so it's y. X squared is what's being graphed on the x-axis, so it's x. And A must therefore be the slope. So when it says calculate A, you're just finding the slope. Here is the final way you will lose points because the AP Physics scorers are crazy. If you calculate the slope of this line, you have to do it by hand, usually, unless it says otherwise. And here is the part that you're going to be angry about. If you use any values from the table, right? These are the values on the x-axis that we plotted. These are the y. You might be very, very tempted to just take 2 of the y values and 2 of the x values and do y2 minus y1 over x2 minus x1, because why wouldn't you? That's what you've done your whole life. You would get 0 points for that. Instead, you must calculate the slope of this line manually, in most cases, by choosing 2 points that are actually on the line. And since all 5 of these data points are slightly above or below the line, you could not use any of the ordered pairs up here in the table. Instead, here's what you will do to earn full credit. You're going to choose 2 points anywhere on the graph, doesn't matter where, that are actually on the best fit line. And since they are not data points, you have to mark them so that the scorers know which points you use to calculate the slope. So the best ones, I think, are here. We have an intersection 0.03, 50, and here. There's an intersection 0.06, 100. The way you mark these points is with a plus sign, or sort of a crosshairs symbol. You put a plus here and a plus here. And then next to each of those 2 pluses, in parentheses, you will write the ordered pair corresponding to the point you've marked. So, for instance, up here at the top, you'd go plus, and then parentheses. I know I'm not drawing right now. I don't know how to do that. Sorry. But you do parentheses, 0.06, comma, 100, close parentheses, and then do the same down here, this other data point. Then you show the slope calculation manually, so y2 minus y1, blah, 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 and you show all those numbers from the ordered pairs you have indicated on the graph. That is how you earn full credit on graphing questions.